Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today, we're going to be going over proportions. And that begs the question, what is a proportion? Well, for our purposes, guys, a proportion or a proportional relationship or proportional relationships will always refer to equivalent ratios. And by now, we should know that we can express ratios as fractions. For example, we can have a ratio of 2/3, and granted, that 2 could be anything, 2 chocolate bars for every 3 pieces of candy, or 2 boys for every 3 girls in a classroom, or I don't know, 2 cloudy days for every 3 sunny days, etc. So at this point, I just want to focus on the fractions. So again, when we have a proportion or a proportional relationship, we're saying that that set of fractions or that set of ratios are all equivalent to each other. For example, I want you to observe this first pattern right here. So we have 2/3, 4/6, 8/12, 16/24, 80/120. And the question is, what do all of these have in common? Well, ladies and gentlemen, if you notice, all of these fractions will simplify to 2/3. In other words, 4/6, 8/12, 16/24, and 81/20. Each of those fractions, if you simplify them, they will each simplify to 2/3. For example, if I take 4/6 and divide 4 and 6 both by 2, notice that I'm dividing them each by the same factor. That's going to give me 2/3. 8/12, if I divide 8 and 12 each by 4, that's going to give me 2/3. And then 16, if I divide 16 by 8 and I divide 24 by 8, that again, 16 divided by 8 will give me 2, 24 divided by 8 will give me 3. And similarly over here, 80 divided by 40 will give me 2, and 120 divided by 40 will give me 3. And that will be the simplest form of that fraction. So they're all equivalent to 2/3, which makes each of these fractions equivalent to each other. So yes, I am saying that 16/24 is the same thing as, or has the same relationships, the same ratio as 4/6, which is the same thing as 8/12, which is the same thing as 8/120. And granted, there can be an infinite number of fractions that are equivalent to each other, but at least for now, this set of fractions, these are all equivalent to each other. So I can call this a proportion. It is a set of equivalent ratios. Each of these is proportional to the other. Now, before I continue, ladies and gentlemen, whenever you're given 2 fractions, there's several things that you can do to test to see if they are indeed equivalent, to see if they are proportional. For example, if I start with 2/3, and let's say that I wanted to compare that to 4/6, and the question is, are these equivalent? Do these make a proportion? Well, ladies and gentlemen, some of you guys may be familiar with a process known as the butterfly method, otherwise known as cross multiplication. Now, bear in mind, I am not going to multiply the fractions. If I was multiplying the fractions together, if I was going to do 2/3 times 4/6, then I would just multiply the numerator with the numerator and denominator by denominator. But that is not what we're doing right now. Again, that is not what we're doing right now. Instead, I'm going to use multiplication, specifically cross multiplication, to test to see if these fractions are equivalent. What do I mean by that? Well, I'm going to multiply the denominator of one with the numerator of the other. For example, I'm going to multiply 3 times 4, or 4 times 3, and I'm going to multiply 2 times 6, or 6 times 2. And I'm going to put the products on top. So 3 times 4 is equal to 12. And 6 times 2 is, that's also equal to 12. So ladies and gentlemen, what this is telling me is that because the cross products are the same, 3 times 4 is 12 and 6 times 2 is 12, that means that these 2 fractions are indeed equivalent. That is what cross multiplication does. That is what the butterfly method is used for, to test to see if they are equivalent. All right? I'm not producing a different fraction by doing that. No, I'm just testing to see. So once again, ladies and gentlemen, all of what I did is that I multiplied 3 times 4, which that gives me 12. And I multiplied 6 times 2, and look, that also gives me 12. So what that is telling me is that these 2 fractions are equivalent. And notice that I can do that with any two of these fractions. For example, let me try that again, but this time let me do 2/3. And let's see if 2/3 is the same thing as 8/12. Let's see if 2/3 is the same thing as 8/12. So let me go ahead and do the cross product. So let me go ahead and multiply 3 times 8. And I know that 3 times 8 is indeed 24. And I can do 12 times 2. And 12 times 2 is indeed 24. So because they gave me the same cross product, I know for a fact that these two fractions are equivalent. Now you can take any two of these fractions and you're going to see that they are indeed equivalent. All right. So, ladies and gentlemen, not only that, but just as I kind of did earlier, notice that if I take 2 and I multiply 2 times 2, that will give me 4, right? And ladies and gentlemen, if I can multiply 3 times 2, and if that indeed gives me the bottom one, 6, then these two are equivalent. And is 3 times 2 actually equal to 6? Yes. So notice that whenever you multiply or divide the numerator and denominator by the same factor, if the resultant fraction, the resultant fraction will be equivalent. For example, ask yourself, 2 times what will give me 8? Well, I know that 2 times 4 is going to give me 8. So if I multiply 3 times 4, it should give me 12. And is 3 times 4 actually equal to 12? Then yes. So I know that these two are equivalent. And I can do that with other fractions. For example, 4 times 2 gives me 12. I know that that gives me 12. So I can ask myself, 6 times what gives me 12? Well, it's also 2. And notice that because it's the same factor, these two fractions are equivalent. Okay, let's table that for now. We're going to see that same pattern again later. But notice that down here, we also have another proportional relationship. Let me go ahead and zoom in down here. Notice that we have 50 over 100, 25 over 50, 10 over 20, 5 tens, and 1/2. Now, what do all of those fractions have in common? What do each of those ratios have in common? Well, each of those ratios will simplify to 1/2. Each of those ratios represents half. 50 is half of 100, 25 is half of 50, 10 is half of 20, 5 is half of 10, and 1 is half of 2. And yes, each of these will indeed simplify to 1/2. Actually, sorry. I can divide both of these by 50, and that's going to give me 1/2. I can divide both of these by 25, and that's going to give me, again, 1/2. I can divide both of these by 10, and that's going to give me 1/2. And I can divide both of these by the greatest common factor of 5, and again, that's going to give me 1/2. They each simplify to 1/2. So I know that they're all equivalent. They all mean the exact same ratio. It's the same relationship. Different numbers, but the same relationship. Similarly, ladies and gentlemen, I could cross multiply any two of these fractions, and it will give me the same cross product. For example, here, 50 times 10 is 500. 20 times 25 is also 500. So guess what? Those are equivalent. Let's say if I did 100 times 10, that's going to give me 1,000. Well, guess what? 20 times 50, that also gives me 1,000. So those two are equivalent, etc. Again, you can test any two of these fractions. And also look at this, ladies and gentlemen. I can ask myself, 50 divided by what gives me 25? Well, I can divide it by 2. And ladies and gentlemen, if in these are indeed equivalent, I should be able to divide this by 2, and it should give me the denominator. And yes, 100 divided by 2 is 50. So notice that I'm doing the same thing in the numerator and the denominator. And sometimes it's not terribly obvious. For example, 25 divided by what gives me 10? I mean, it does work, but it would be a decimal. And so I wouldn't use 25, but ladies and gentlemen, notice that I can use 50. Again, these two are equivalent, so it doesn't matter which one I use. So I'm going to use the one that is more obvious. 50 divided by 5 is going to give me 10. So I'm going to divide 100 by 5. Now, 100 divided by 5 is indeed 20. So again, these two are equivalent. So as you can see, because they're all part of the same pattern, they're equivalent. It doesn't matter which fraction I use to test. I'm going to get the same pattern. Well, the question then becomes, well, why is this important? When am I ever going to use this? Well, ladies and gentlemen, we use this in all sorts of different situations. For example, let's suppose that you're going to make a recipe that requires 2 eggs for every 8 cups of flour. 2 eggs for every 8 cups of flour. Well, number one, ladies and gentlemen, notice that this is basically a ratio. Okay? We're comparing eggs and flour. Eggs and flour. You can think of that as a fraction. We have eggs on the numerator and cups of flour in the denominator. And here's that exact same ratio. We have 2 eggs. Here's in the numerator. Everything in the numerator has to do with eggs. And here's 8 cups of flour. So we have 2 8s. That is my ratio. 2 what? 2 eggs for every 8 what? 8 cups of flour. But let's suppose that you open up your pantry, ladies and gentlemen, and instead of having the 2 eggs necessary to make that recipe, you only have 1 egg. You only have 1 egg. So can you not follow the recipe? Well, of course you can. You just have to make a smaller portion. You have to make a smaller portion. But if you want it to taste the same, you want to make sure that you have the same relationship between the eggs and the cup of flour. So how can you do that? Well, ladies and gentlemen, how can you get from 2 and make it into a 1? Well, obviously, we need to divide 2 by 2, right? But since I'm doing that to the numerator, I have to make sure that I do the same thing to the denominator. So what do I have to do to the 8? Well, I have to divide 8 by 2. And guys, what is 8 divided by 2? Oh, well, that is 4. So what that means, ladies and gentlemen, is that the resulting fraction, 1/4, is the exact same. It is a proportion. It is equivalent to 2 8s. And in the context of what we're doing here, ladies and gentlemen, that means that 1 egg, for every 1 egg, I need 4 cups of flour. Since I don't have the two eggs with 8 cups of flour, I can use 1 egg, and instead of using 8 cups of flour, I'm going to use 4, and it should be the same proportion. It's the same recipe. Let me show you that one more time. So again, we're basically asking ourselves, 2 8s is the same thing as 1 over what? Well, to get from 2 to 1, I need to divide 2 by 2, right? Because 2 divided by 2 is 1. So that means that I need to do the same thing on the denominator. I'm going to divide 8 by 2. Notice that I'm dividing by the exact same factor. 8 divided by 2 is 4. What if we do the opposite? Let's do the opposite. So we know that this is a 4. So what if you had a lot of eggs and you wanted to make a bigger portion of the recipe, but again, you want to follow the same recipe. You want it to taste the same. So let's say you have 6 eggs like we have here. We have 6 eggs. Well, what can you do to this 2 to make it into a 6? Well, this time, obviously, I have to multiply. So 2 times 3 is 6, right? So I need to follow that same pattern. So we need to multiply 8 times 3. We're going to multiply 8 times 3 to get to 8 times 3 is 24. So yes, ladies and gentlemen, 6/24 is the same thing as 2 8s. Or in the context of what we're doing here, to follow the recipe of 2 eggs for every 8 cups of flour, well, if you use 6 eggs, you better have 24 cups of flour to make the exact same recipe for it to taste the same. So ladies and gentlemen, what I am saying is that 1/4 is the same thing as 2 8s, which is the same thing as 6/24. And I can use any of those fractions to complete the table. For example, again, we know that this is 4 and we know that this is 24. But let's suppose that you want to make a lot. You want to make a very large batch. Let's say that you want to, and again, this is 24. This is a 4 down here. You have 40 cups of flour and you're like, hey, I need to go to the store. I need to get enough eggs to use all 40 of those cups. I want to make a lot of this cake. Well, notice, ladies and gentlemen, that I wouldn't use the 6/24. Even though you can make a fraction over 40 that is equivalent to 6/24, you have to ask yourself, 24 times what gives you 40? That is possible, but it's going to be some decimal or fractions, so that's not the easiest route to go by. So instead, ladies and gentlemen, I'm going to use one of these 2 fractions. I can use 1/4 or I can use 2 8s. If I use the 2 8s, notice that 8 times what gives you 40? Well, obviously 8 times 5, right? And if I'm multiplying the denominator by 5 to get to 40, well, guess what? I'm going to multiply the numerator by 5. Which numerator? Well, the same numerator right here, 2. So if I'm multiplying the 8 by 5, I need to multiply the 2 by 5, and 2 times 5 will give you 10. You need 10 eggs if you're using 40 cups of flour. Now, what if I had used this other one? Well, 4 times what gives you 40? Well, 4 times 10 gives me 40. So I need to multiply 1 times 10. And 1 times 10, guys, gives me 10. Gives you the exact same answer. And here we see the same thing with 64. I could multiply 4 times 17 to get to 64, but I think the easiest one is actually 8, because 8 times what gives me 64? Well, I can multiply 8 times 8. But if I'm multiplying that by 8, then I must multiply that 2 times 8 also, and 2 times 8 is 16. Ladies and gentlemen, 1/4 is equivalent to 2/8, which is equivalent to 6/24, is equivalent to 10/40, which is equivalent to 16/64. And I can do that for any random number that I choose down here. Let's suppose that you want to use 100 cups of flour. Well, I think the easiest one here would be 4. 4 times what gives me 100? So that would be 4 times 25 to get to 100. So 1 times 25 will give me 25. So yes, 25 over 100 is the same thing as 1/4, which is the same thing as 2/8, which is the same thing as 6/24, etc. You can use any numbers. So that's relevant for a few examples that we can see from our very own textbook, ladies and gentlemen. In fact, if I go and look at the textbook for this specific assignment, if I go down to page 277, just give me 1 second. To the very bottom. There it is. Notice if I focus here on number 3A, So here it's a little bit of a different format, and yet it's the exact same thing we just did right now. Notice that here we're comparing teachers and students. So we're not doing eggs and cups of flour, but it is a ratio. We are comparing two different things. We have 2 teachers for every 26 students. So I'm looking at this example right here, 2 teachers for every 26 students. And the question is, well, if we follow the same ratio, the same pattern, let's create a proportion here. Let's create an equivalent ratio. But this time, instead of 2 teachers, we're going to have 8 teachers. And the question is, well, how many students do you need or in order to have the same ratio? Well, let's do the exact same pattern we did before. Ladies and gentlemen, obviously, I'm not going to work with the denominators, but I can work with the numerators. How can I get from 2 to 8? What can I do to the number 2 to get to 8? And you're either going to multiply or divide. So in this case, I'm going to multiply 2 times 4. And since I'm multiplying the numerator by 4, I'm going to multiply the denominator by 4 as well. So I need to multiply 26 times 4. So 26 times 4, 4 times 6 is 24. 4 times 2 is 8, plus 2 is 10. Ladies and gentlemen, that means that in order to have the same ratio, in order to have the same relationship, you would have 104 students. So on Schoology, the answer would just be 104 because we're asking about the students, 104. It looks like a 9, but that's a 4. All right, same thing. What about this other one? Let's do a couple more examples like this one. Let's do letter B. So we have 12 inches for every 1 foot. 1 foot is 12 inches. So what if we have 18 feet? So obviously I can't yet work with the numerator, but let's look at the denominator. Well, how do I get from 1 to 18? Remember, we're going to multiply or divide. Well, in this case, it's getting larger, so I'm going to multiply 1, and I know that 1 times 18 is 18. So guess what? I need to multiply 12 times 18. So I'm going to work that out. 18 times 12. So 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. We're done with the 2. 1 times 8 is 8. 1 times 1 is 1. And I add these together to get 8, 9, 10, 11, 216 inches. At Schoology, I would just type in the number 216. So if you have 12 inches for every 1 foot, then 18 feet, you would need, it would be equivalent, or you would need to have 216 inches. All right. Now, what if we have to divide? What if we have to get smaller? Like, for example, if I look at here at letter F, let's look at letter F down here. So the 2 things we're comparing are boxes over truckloads. And so I notice that I'm going from 9 to 3. So what do I do to 9 to get to 3? Well, obviously, I need to divide 9 by 3 because 9 divided by 3 is 3. So I would divide 1,200 by 3. And 1,200 divided by 3 would be 400, right? Or 400 boxes. So notice it's the same pattern each and every time. Now, sometimes, ladies and gentlemen, instead of having a pattern like this, you're gonna be given a table. all right, like you are in page 289, which is the second part of this specific assignment, but it's going to provide us with some good examples. So going down to page 289, notice that we're just giving a whole bunch of tables, and we're always comparing yellow daffodils and white daffodils, but it's the same thing as we did with eggs and cups of flowers. Just it's a ratio, it's two different things. But you can think of this as a pattern. All right, so 9/15 is the same thing as 36 over what, same thing as 45 over what, and which is the same thing as something over 90. So ladies and gentlemen, you can, it doesn't really matter how you go, you can go straight to the very last one. You can ask yourself, well, 15 times what is 90? Well, I know that 15 times 6 is 90. So guess what? I have to multiply 9 times 6. And if you didn't know that 15 times 6 is 90, that's okay. You can just do 90 divided by 15, and 90 divided by 15 is 6. So 15 times 6 is 90. So 9 times 6, notice that I'm multiplying the numerator and denominator by the same factor. That would give me 54. Now, I could have started with a different one. I know that 9 times what gives me 36? Well, that's times 4, is it not? So I need to multiply 15 times 4 in that case to figure out what goes down here. And 15 times 4 is 60. So notice, just whatever you use for the numerator, use that same thing for that denominator to create the new denominator. And it's the same pattern each and every time. Well, ladies and gentlemen, this video is long enough, but I hope that you found this helpful. And with that in mind, I will see you next time.